Welcome back to the Erica Show. 안녕하세요. 에리카쇼의 호스트 에리카입니다. I'm your host, Erica from Crypto Soul, and I talk to the top builders and leaders in the crypto space. And in today, episode 38, Justin Drake, researcher from Ethereum Foundation, joins the show. This should be a fun one, and I'm very, very glad to have Justin with me. Hi, Justin. Welcome to the show.
Hi, Erica. Thanks for having me.
It's been a long time since we last met, and I'm, so glad to reunite. Although it's online, but still, it means a lot to me. Thank you so much for coming.
Yeah, for sure. I mean, when was the last time we met? Was it in
2018? It was 2018 April. I remember. And we had the meetup.
Wow, a long time ago.
Yeah, I remember. Good times. And I feel like decades have passed since then. I hope you're safe and, doing well. You seem well. But it's really good to reconnect. And, so much has happened in, Ethereum Foundation is all, an Ethereum community. So it's so nice to, catch up and hear your insights. So yeah, thanks so much. And, for the general, public and for those of people who might not know who you are, can you just a brief introduction of who you are and what you do in Ethereum Foundation?
Yeah, for sure. So I'm Justin Drake, and I'm a researcher at the Ethereum Foundation. Most of my work has focused on Ethereum 2.0, which is basically a name that we give to a set of upgrades to Ethereum. And the two big upgrades that we have are one, proof of stake, and two, sharding. And I've been at the Ethereum Foundation for a bit less than 4 years now. I do all sorts of stuff there, including trying to help produce the spec. So basically, there's some research that goes towards designing the protocol that we want with the goals that we have in mind, and then the Ethereum Foundation writes the spec, and then we have a bunch of teams around the world that go implement the spec. So kind of my job starts at the research and kind of ends at the spec. And during this process, there's, crypto economics, which is basically the combination of cryptography and economics. So part of my job is kind of trying to understand cryptographic primitives, at the very least, trying to understand the property that they give us, and then see how we can use these powerful cryptographic tools in combination with incentives to build these powerful decentralized protocols.
Wow, that's very complicated. That's a lot in one sentence, but crypto economics is definitely a fascinating topic. But I think it's still, under research. I think it has much, much more potential to be researched on. And, you're one of those pioneers in in that space as well. And I think a lot of the Korean engineers also find you very active in, bringing out new ideas. And so, it's really meaningful to have you with us, because I think you're one of the, active ones for sure. And, so you mentioned about cryptography and economics, but was your background mainly in that? I mean, what was your background before crypto, BC, basically? How did you get into this rabbit hole?
Right. So my background is mathematics. That's what I studied at university. And I guess you could say that cryptography is a sub-branch of mathematics. So I didn't study any cryptography. I wish I did at university. It was, I had, I guess, enough background that I could teach myself, all the basics. So the ability to kind of reason abstractly and to read, academic papers, all of these skills I was able to reuse in the context of cryptography.
Right. And, your role in the Ethereum Foundation is definitely crucial. And I can see that you're involved in many things. Just curious, your journey has been pretty long. It's been more than almost 4 years, as you just mentioned. And how has your role developed, progressed? And, I think a lot of people wonder, what it is like in the Ethereum Foundation, making all these big changes. And it's just really fascinating to see it from an outsider's point of view. So just curious, how has your journey been so far?
Yeah, I mean, it's been a great journey. I mean, I think at the Ethereum Foundation, things are not very hierarchical. You have a lot of independence, and you're actually expected to be pretty proactive. And as such, you get to craft your own path. and you get to choose the problems that you work on. Like early on when I came in, it was a relatively early days for the design of Ethereum 2.0. A lot of the ideas that Vitalik had were very visionary, and they were correct directionally, in terms of proof of stake and sharding, but there was a lot of the detail that had to be worked out. So early on, I was basically doing what you'd say, the design or the research. But then, after maybe a year and a half or 2 years, there was a need to communicate all these ideas and formalize them and have them implemented. And basically, the next step is the spec work. So I've helped to an extent, with the delivery of the spec, which is not so much blue sky research, but it's just a matter of having a system which is practical. And I guess we're now in a great position in terms of both the research and the spec writing, that I have time to do other stuff. And one of the things that I've been helping is basically indirectly help the implementations. So one of the key things that we want to get right for proof of stake is security, right? Like the whole point of proof of stake is to be a security mechanism for Ethereum. And besides the security and of the protocol itself, we want the implementations to be secure. That means removing bugs. And so one of the things that I've helped with, for example, is hire a security team within the Ethereum Foundation that is dedicated to security and that can look at all the clients at the same time. And this is especially critical because we're anticipating the so-called merge, where we replace the security system from the current proof of work to proof of stake. And so we're going to be placing hundreds of billions of dollars of value on top of this new system, which needs to be robust.
Yeah, it's definitely going to be a huge change and a milestone for Ethereum. And, as you mentioned, security is definitely the primary, very important, crucial for the team as well. I remember back in 2018, even Ethereum Foundation was very primitive. I mean, I think it was very beginning stage, I guess, in terms of formalization, organization. So it's really fascinating to see the development and progress so far. And I'm sure you were in the center of it. So and let's now kind of dig into the more conceptual, I guess, definitions for the audience. I think a lot of people really were thought of EIP 1559. They've always seen on the media, and everyone's very curious how it's going. It's been live for about 20 days. 100,000 Ethereum has been burned. How does this what does this imply, and why does this matter to Ethereum?
Right. So I guess EIP 1559 has to do with kind of Ethereum 1.0, which is the Ethereum as it exists today, distinct from the proof of stake and the sharding. And basically, it does many things. So one of the things that it does, for example, is it improves user experience. So the way that it does that is when you want to transact with Ethereum, you get to know how much you need to pay to transact with Ethereum. Previously, there was this so-called first price auction where you kind of needed to guess what other people were willing to pay and then make an educated guess on your bid price. And sometimes you would underbid, and so your transaction wouldn't get included. Sometimes you would overbid, and you would effectively overpay for inclusion. And so the user experience was pretty bad. And so that's one of the things that EIP 1559 improves, is the notion of a quoted price or a posted price. Basically, the protocol tells you what you need to pay. Another kind of nice improvement that EIP 1559 provides is in terms of security. So transaction fees in general are a little bit of a liability for the security of Ethereum. And the reason is that transaction fees can be stolen from one block to another. So for example, if there's a transaction which is happy to pay a very, very high gas price because the person making that transaction really cares transaction going in, and it could be thousands of dollars, then as a block, basically as a miner or as a validator in the context of proof of stake, you have to decide, do I build on top of the block that includes this value? Do I build on the parent of that block and kind of steal this valuable transaction and put it in my own block? And it turns out that if the delta between the transaction fees and the issuance is large enough, then sometimes the incentives get misaligned and you have forking. And so one of the things that EIP1559 does is that it just reduces the amount of fees that can be extracted by the miners or the validators. And as such, it kind of improves the stability of the chain.
Right, right.
And then there's a final thing that EIP1559 provides, and this is something that the community is very excited about, and you mentioned, is the burn, the fee burn. And this has kind of economic and monetary consequences. And what's happening here basically is that EIP1559 is converting transactional utility. So all the utility that Ethereum provides is getting converted into monetary energy, basically, by destroying circulating ETH and providing a deflationary pressure on the supply of ETH. And one of the reasons why this deflationary pressure is exciting, beyond kind of the fact that that it exists, is that it also changes the narrative. And the reason why it changes the narrative game is because we will actually be in a position which is rather unique, where the total supply of ETH will go down over time. So more specifically, the total fee burn is roughly 4 times as large as the proof of stake issuance. So once we only have proof of stake issuance, once we remove the proof of work issuance, we'll be in a position where the ETH supply decreases, and it's kind of taking the idea of a cap supply gold or cap supply Bitcoin to the next level, where you basically have a decreasing supply. And changing the narrative game is important if one of your goals is so-called monetary premium. If you want to basically have an asset which society agrees is special in some way and should be valued as such.
Right, right. Yeah, I think the last comment really led up to my next question. But my question was like, how does it improve the monetary value of Ethereum? But I think, as you mentioned, the quantity will likely to plateau. Basically, the amount of the amount will not decrease, but it will plateau at a certain point, and that will I guess scarcity is definitely, and the limitation of quantity is it brings up the value of something. But does that relate to this monetary value? And I think some people don't know that this some people assume, many people assume actually, that Ethereum quantity is limitless. It's gonna just keep going up and up and up, and it's that's why it's different from Bitcoin, for example. But what do you think of this point of view? Because I think many people don't know this very fact that you just mentioned. So it's very interesting.
Right. So there's kind of 2 components to the supply growth over time. One is the issuance, which is how much ETH are we producing every unit of time to secure Ethereum. And right now it's roughly 13.5 thousand ETH every single day to secure ETH with proof of work. And it's about 10 times less for proof of stake. And one of the things that we've decided upon kind of as a community is on this policy of minimum viable issuance. Now, what does this mean? It means that we want to have the smallest issuance that we can, which still provides security. That's what viable means, right? If the issuance is too low and it can't guarantee security, then we're jeopardizing security, and we're in a bad position, because security is one of the core things the core value propositions of Ethereum.
Sure.
So we have minimum viable issuance, and the way to achieve that is with proof of stake, because proof of stake is so much more efficient than proof of work to provide security at a low cost. And then the other part of the equation is the burn. Now, in theory, if there was no burn, the idea that the ETH supply is uncapped and could grow, indefinitely is actually correct, right? Because every year we're going to have this amount of issuance. And for proof of stake, just to give you an order of magnitude, it's at most 1 million ETH every single year. So if there's 120 million ETH, then we're talking less than 1% inflation in the worst case every single year. But the reason why this take that the ETH supply is unbounded is kind of a little unsophisticated, or it lacks nuance, is because of this fee burn component. And because Ethereum has grown to be the most valuable blockchain to transact on, you can have a look at raw transaction fees, where an order of magnitude larger than the second next blockchain, and the fact that we're able to capture all this utility through the burn means that almost certainly when we merge, which should happen in, let's say, 6 months roughly, we will be in a position where the ETH supply will decrease.
Right. Thank you for the explanation. It's been, I think, people grasp the idea, but it's just like, I think the whole process seems a little bit complicated for the general public, but yeah, as you explained so well, thank you so much on that. And there's this, I think a lot of people also see the term ultrasound money. It's been in a lot of your previous interviews, and people wonder, they wonder what is sound money and what is ultrasound money, and why is this, like, I guess it's a bullish version of sound money, but what does it exactly mean? And can Ethereum become ultrasound money? Can you elaborate more on that? Your previous interviews, like, I just want to kind of elaborate more on that and just hear your point again. And yeah, it's very interesting point of view.
So I guess before understanding ultrasound money, as you said, it's good to understand sound money. But before understanding sound money, maybe it's good to understand money. Okay. So I'll kind of walk my way through, starting with money. So for me, money is basically a money candidate with monetary premium. Now, what is a money candidate? A money candidate is an asset which has various very important properties. That means that it could, in theory, in the future, be used as money. So what kind of technical properties do we want? We want things like divisibility, fungibility, durability, transmissibility, and that's kind of a laundry list of properties that are good to have if you want money. An extreme example of something which is not money would be a cow, for example. A cow is an asset, but it's not easily divisible, it's not fungible, the head is not equivalent to the tail, it's not easy to transport, there's all sorts of issues. That's the starting point, a monetary candidate. And then once you have a money candidate, you need the notion of monetary premium. So what is monetary premium? Is this magic, and basically it's society coming to this monetary candidate is special in some way and deserves a monetary premium. And one good example here is gold, right? So gold, if it is used as an industrial metal, for example, in iPhones, and this gives it utility. And if we were to try and value gold purely based on its industrial utility, it would be worth roughly $1 trillion. But it turns out that gold has a much, much higher market cap. It's around $12 trillion. And so this $11 trillion discrepancy is the monetary premium that is not derived from utility, but instead is derived from just this societal illusion that this thing is valuable, precisely because everyone kind of has this shared illusion. Okay, so that's money. Now, sound money is money with one extra very important property, which is that essentially no one can debase the money. So what does debase the money? It means that someone could arbitrarily increase the supply. Mm-hmm. Now, one example of unsound money, for example, historically is salt. Right, so you could salt was used as money, but as soon as someone makes an industrial breakthrough and is capable of producing salt en masse, then effectively that one entity was able to arbitrarily debase the salt supply. Right. Another example of unsound money would be fiat currencies, where the governments have the ability to debase the currency, and this we've seen a lot during the coronavirus situation. And so examples of sound money are gold, for example, or Bitcoin. And actually the etymology of sound money is from gold and silver. Sound money used to be called sound money because the gold and silver coins would make a very characteristic sound when you would bang two coins together. So you'd put a coin on your finger and you take another coin and you bang them together and they go bing. Mm-hmm. And if it makes the correct kind of ping, then you know that it's real sound money. And I guess the meme, the ultrasound money meme, is kind of taking this no debasement idea to the next level, where over time the supply is actually shrinking. So you could think of the supply kind of rebasing, the opposite of debasing. There aren't any kind of monies that have this property today. All monies are either inflationary, like fiat currencies, or so-called disinflationary, meaning that the inflation reduces over time, such as gold and Bitcoin, but we don't really have deflationary monies. And this is something that Ethereum provides.
Deflationary. Yeah, absolutely. And you explained money in a way, but there was a metaphor that you also used. Was it solid, liquid, and gas metaphor? And it was very fascinating, and I really liked it. And solid is like asset, and liquid is like money used in payments, and gas like fuel, and then smart contracts within the crypto ecosystem. And maybe that I'm not elaborating enough, but if you can you describe more on what that metaphor is about, and how did you come up with this metaphor? And this is the way you explain it is really, I think, intuitive to a lot of people. So just wanted to clarify that as well.
Yeah, sure. So I basically use the metaphor of money as water to describe three scarcity engines in the context of Ethereum. So Ethereum is used as money in three different ways. So Ether is used as money within Ethereum in three different ways. The first way is in the context of staking. So basically you're taking liquid Ether and you're so-called freezing it. You're bringing it to the less than zero territory. And once you are a validator with this frozen Ether, which is basically collateral, you can't touch that money. And so that's why the frozen metaphor is meaningful. And if you want to unstake, basically if you want to defreeze the money, this process takes time. So I guess you could imagine staking as this giant ice cube, which is roughly $25 billion large. And if you want to liquefy it, then it will take many, many months to go back from solid to liquid. Another scarcity engine, which we've talked about, is the fee burn. Whenever you make a transaction on ETH, part of the fees get destroyed. And you can think of it as taking liquid ETH and vaporizing it, destroying it by turning it into vapor. And so that kind of corresponds to the hot side of the spectrum, where you're taking liquid ETH and you're making gas ETH, and this gas will kind of leave the supply and And then there's the final scarcity engine, which is DeFi. There's a million ETH that is used in the context of DeFi, and DeFi uses ETH in a very similar way to staking. It uses it as collateral money.
Right.
So one good example is Maker. It's a stable coin which is collateralized by ETH. And so you can think of the third scarcity engine as being water trapped in the pipes of DeFi. And so in their own ways, each scarcity engine kind of removes or reduces the liquid supply of ETH.
Wow, thank you. I mean, I thought a lot of people asked about the metaphor, and I think your previous interviews really had a lot of, I guess, metaphors and insights. So the people wanted to hear more of your descriptions about it, and thank you for that. And for you mentioned DeFi. I just wanted to ask your opinion on this, but I think Ethereum is definitely Ether is definitely used heavily in DeFi, and also NFTs these days. But just a side question, but where do you think, Ethereum is most applicable for usage? I mean, I guess it's right now it's all like in DeFi and NFT, but in your perspective, where do you think it's kind of crucial? Or I guess, I just wanted to hear your focus and of interest. I was curious. Do you have any insights on that?
Yeah, so I try to be a little agnostic and kind of open-minded to everything that comes to Ethereum, partly because, the whole point of Ethereum is to be permissionless and kind of to allow for this, unbrindled creativity to come in. And kind of, and this is very similar to the internet, where the internet, it was difficult to predict, what would come later on. It was impossible to predict Twitter or Facebook, in the early days of the internet. And I think we're in a similar situation. But I mean, I think the overarching kind of theme is what I call the internet of value. And so whenever you have some sort of digital asset which carries some value, and this could be fungible tokens in the context of DeFi. It could be non-fungible tokens in the context of art or gaming. Whatever it is, they kind of fall under this Internet of Value umbrella. And Ethereum is basically providing the trust platform where the innovation can happen in a permissionless manner. Without the need for intermediaries. Right.
Yeah. So I guess agnostic is probably the answer to the question. Yes, very politically correct question answer. But thanks for that as well. So one of I think your comments was very fascinating to me was the fact that you mentioned Ether is Satoshi's vision coming into fruition, I guess. How do you pronounce that? But that was, I think that just kind of ringed a bell in a lot of people's minds. And can you elaborate more on that? Because I think a lot of people, there's been some debates about it, to be honest. And I think I think the Korean community is also very fascinated with your insights. But can you elaborate more on why you believe that is the case?
Right. I mean, it's very difficult to peek in Satoshi's brain.
Of course.
So the best we can do if you want to try and understand what he was trying to achieve, but we can have a look at hints that he left. So one of the hints, which in my opinion is pretty meaningful, is that in his very first public commit, so basically when he publicly revealed the source code for Bitcoin, there was the beginnings of a decentralized peer-to-peer marketplace. Now, this marketplace would basically provide utility for the money, namely BTC asset. So, in my opinion, it's likely that Satoshi wanted to build an internet of value which goes well beyond the digital gold idea, right? Digital gold is very similar to physical gold in the sense that it's all about hodling. I mean, if you think of gold as kind of this crazy thing where we spend so much energy to unearth gold, and then we just put it back in earth in vaults, and then we don't touch it.
Right.
This is what BTC, the asset, is today. It has very little transactional utility, and it's used as a digital gold. And I think one of the things that Ethereum unlocks is the ability to not only have this monetary base, but take it and use it as the foundation for an internet of value. Now, when you think of a marketplace, there's actually many different moving parts that you need to get right. So for example, you need an identity system. And on Ethereum, we have the Ethereum name system, which is a good start. You need escrow contracts, right? So if I'm buying something from you and it's a physical item, there needs to be some sort of moderation if there's a dispute. And, the Ethereum platform to build such an escrow contract. You might need the concept of decentralized insurance, right? If you're trying to build, for example, an equivalent of Uber or eBay, and this is yet again a layer of the stack that is being built on Ethereum. You might need decentralized reputation. You will almost certainly need decentralized stablecoins, and that is yet again something that Ethereum is providing and that Bitcoin is not catering for. So in that sense, where you have these money Legos which can be combined to provide a meaningful system like a peer-to-peer marketplace as part of the Internet of Value, I think is where Satoshi's kind of very ambitious long-term vision was in mind. He had to start somewhere, and I think digital gold is indeed the correct starting point, but it is not the end goal. The end goal is much, much larger than that.
Wow, fascinating. Yeah, that makes sense. And just speaking about like comparing, this is in line with like this Bitcoin Ethereum talk, but Bitcoin is definitely known for like the store of value, I guess, proposition, but that's one of the fundamental advantages of Bitcoin, I guess. But can Ethereum be a better store of value in that sense? What is your take on that? And I'd love to hear insights on that as well.
Yeah, so it turns out that in the decentralized place, there's a huge interplay between the utility and the memes. So, and by memes, I mean the monetary premium. So let me try and explain that. And maybe the easiest is in the direction from the memes to the utility. How do we provide utility? Well, if we have monetary premium, that means that the total supply of ETH is greater, and that gives us two things. The first thing that it gives us is it gives us greater security, right? And so security is the basic utility that is being provided by Ethereum, and so memes give us utility. But there's a second big way in which memes give us utility. It's the concept of economic bandwidth. Right. So if we go back yet again to this example of a stable coin, we can only mint as many stable coins as we have collateral in ETH. We're kind of bottlenecked by the amount of collateral. And right now, the amount of DAI, which is the stable coin on Maker, in circulation is about 6 billion DAI, which corresponds to $6 billion, which is absolute peanuts in the kind of the scale of the world, right? We want $6 trillion, not $6 billion. So we're kind of off by 3 orders of magnitude. And the only way to have an asset which is valued at such scale is to have monetary premium. So that's one direction, like monetary premium giving us 1, economic security, and 2, economic bandwidth. Now, in the other direction, it's interesting is because, as I mentioned, the way that monetary premium is achieved in the first place is by having an asset which distinguishes itself, which is special in some way. Now, if you look at Bitcoin, Bitcoin is special because it was, for example, the very first, scarce asset, which is fundamentally decentralized and digital. And, you could look at Ethereum as being special for various reasons, for example, because it's programmable. But we need to be, in order to really achieve monetary premium, you need to distinguish yourself in unique ways. And one of the ways which is totally unique to Ethereum is the ability to provide utility at scale. And this goes back to the amount of ETH that we're burning. We've burnt 100,000 ETH in a matter of 3 weeks, which corresponds to about $350 million. And where, for example, roughly 2 orders of magnitude larger than Bitcoin. And by differentiating ourselves in terms of utility, we are in a unique position to achieve monetary premium.
That was the explanation. Thank you so much. Wow. Yeah, it just makes me look in a different way. So like, I think a lot of people would feel that as well. And yeah, the analogy is really awesome that you use always in your interviews. So yeah, let's talk about so you posted some interesting I guess insights or analysis on your Twitter, and a couple of weeks ago you posted a EIP1559 updated projections on Twitter, and that was really it's updated version, and you talked about the original version, but are you more bullish than ever? Can you describe how you in the beginning how you came up with these projections, because it's pretty fascinating to some, and people, I think it deserves more exposure to the community, and how are they meaningful in further research and analysis? Just want to hear on that process of the projections. Yeah.
Right. So, I think initially I tried to try and project the economic situation for Ethereum, because very few people had done it, and the kind of economic landscape of Ethereum was changing dramatically. There are basically 3 ways in which it was changing dramatically. Way number 1 is that the transaction fees were skyrocketing, right. And this was a somewhat new phenomenon. The second aspect was that with EIP 1559, we were going to be able to burn these transaction fees, and it's a little bit difficult for people to fully visualize a system which is not live yet. You need to use quite a bit of imagination, and you need to understand what is going to be built. And then another thing which really affects the monetary story is the idea of removing the proof of work issuance and only having the proof of stake issuance. And this again is it requires a leap of imagination. And so what these projections try to do is basically try to capture, using hopefully reasonable assumptions, the possible futures that we'd have from an economic standpoint. And so one of the things that I looked at, for example, is how will the supply evolve over time? And my projections suggest that the ETH supply will keep on increasing towards a peak at the merge, and that this peak will be at roughly 120 million ETH. Right. And then after the merge, there will be a slow decline, let's say towards some sort of number, which is hard to guess exactly, but let's say 100 million ETH or 80 million ETH. And so over the process of several decades, the ETH supply will be going down and shedding several tens of millions of ETH in the supply. Another thing that I wanted to capture is this idea of reducing the sell pressure. So, right now we're in a position where a lot of ETH is being almost forcefully sold on the markets. And why do I use the word forcefully is because the miners, they have huge expenses in terms of electricity and buying the hardware. And to cover these expenses, they have to sell the ETH that they receive as income. Now, the ETH that they receive as income is coming from two sources. Source number one is the proof of work issuance, and source number two is the transaction fees. And we were in a situation, and we still are in a situation where the sell pressure is extreme. We're talking tens of billions of dollars, like huge amounts of value is kind of being sold every single year to cover for security. And I kind of wanted to compare and contrast the sell pressure that we had with the sell pressure that we will have. And it's roughly a 10x improvement. So instead of having a sell pressure of tens of billions of dollars per year, we're only going to have a sell pressure of a few $billion per year.
Yeah. So, okay. That's a very interesting insight as well. And okay. So the numbers derived from your analysis and, that makes Ether, I guess, super sound, ultrasound, and also that kind of connects to the original, that argument as well, I guess, in the super sound money aspect. But, very interesting insight. And do you have, any further research coming out of it, or is this going to be updated in the upcoming, months? How are you planning to keep the projections? I mean, in terms of open on Twitter, or is this where is this going? Are you going to be doing anything with the research that you just shared with the Twitter community?
Right. So I think one effort is to try and take this spreadsheet and provide it in a format which is more consumable. And so there's this website, ultrasound.money, where, for example, you can try and project the supply based on various assumptions. And so, one of the assumptions, for example, is going to be which date are we going to merge? The later we merge, the more we're going to be minting in terms of the proof of work issuance. And I think ultrasound.money will try and capture more and more parts of the spreadsheet in a digestible fashion. I mean, one of the things that will happen is that as we progress over time, the assumptions will get refined more and more. And so, for example, one of the assumptions that there is on the spreadsheet is what is the percentage of the fees that are being burnt. So there's two parts of the fees, right? There's the base fee, which is burnt, and then there's the tip or the priority fee, which is not burnt. And my best guess before EIP 1559 was launched was that roughly 70% of the fees were burnt. And this turned out to be true, at least in the first few weeks of EIP 1559. But, I'd like for there to be several months until, we can really solidify this one assumption. And then another huge kind of assumption that comes into play is basically how much fee burn is there going to be? What is the total fee volume of Ethereum? One of the things that we've observed historically is that the fee volume denominated in ETH kind of has always gone up, and it's gone up roughly a factor of 10 every 2 years. So over the 6 years of Ethereum, it's gone up roughly a factor of 1,000. And then another variable which is at play is basically how much ETH is staking. Now, the good news is that the proof of stake issuance is so small, it's so tiny that even if it's maxed out, it's a relatively small variable compared to the other ones.
Oh, wow. So yeah, many updates to come. I think it'll be very interesting to see the progress of these projections. And I think they're also very applicable to, I think, further research by, institutions, or, it's going to be very useful because there hasn't been a lot of projections as you mentioned before. So I think this is really great. And you talked about the merge, and it is definitely a fundamental milestone. And this basically means like the date when POW goes away. Well, goes away. POS comes into the picture. But can you explain more like what happens? What really does happen at the merge date, and how exactly is the merge happening, and what is the EF or you preparing for this moment? Yeah, just very interesting milestone. Right.
So if you are a user of Ethereum or a developer of smart contracts, there's very little that you need to do. What will happen is that under the bonnet, behind the scenes, there will be an upgrade, but hopefully, you shouldn't notice anything. Now, in terms of what is actually happening behind the scenes, we're basically changing the security mechanism of Ethereum, as you said, from proof of work to proof of stake. And, conceptually, this is actually quite simple. So right now we have both mechanisms running in parallel, with all the economic value lying on top of proof of work. And what happens at a given date, we just remove one security engine, replace it with another engine, and then just keep going with this other engine. And it turns out that technically speaking, it's also not that complicated. And the reason is because we have two very modular parts of Ethereum, namely the execution layer, which is the EVM and the management of state and contracts and transactions and mempools and all that stuff. And then there's the security module. And these things have a very small interface, meaning that it's actually relatively easy to swap out one of the modules for another version of that module. What makes things complicated are two things. One is quality assurance. We want to make sure that the quality of the new system is extremely, extremely high. And I kind of alluded to that when we're trying to build a dedicated security team to harden the so-called beacon chain, where the proof of stake mechanism is instantiated. And then the other big difficulty is just coordination in the context of, because every time we do these upgrades, everyone needs to upgrade. So every single consensus participant needs to upgrade, every single block explorer, and there's various clients involved, and there's a lot of coordination work to be done. And part of this coordination work involved is formalized. So, for example, we need to write the EIPs, and we need to discuss them, and then we need to have a bunch of test nets. And so there's this whole process that we just have to go through in order to get it out. Yeah, that's a lot of work and legwork, but it's very exciting to have. Do you have a projection on the date? Just kidding. Or do you have any assumption on when maybe probably it might happen in your projections? Right. I mean, I'll project that it won't happen this year. Okay. And I think that's a fairly safe projection. At one point we were trying to target the end of this year, but I don't think it's realistic. Most likely it will be, early next year. So, Q1, Q2, my personal bet would be on Q1 2022. Maybe February, March, that kind of timeline. But there hasn't been, there's of course a lot of uncertainty when you put out these dates, and there isn't a clear delivery date that is being promised by the developers. Instead, the best that we have is kind of these internal and informal kind of targets, which are not meant to be promises, but more so kind of a tool for the developer community to kind of try and coordinate among themselves.
Right.
Because
Yeah, absolutely. It's definitely, you know, an internally set date, but like as you mentioned, there's going to be a lot of trials and errors, and you know, and this process is very complicated. But it's earlier than I expected, so what you projected. So, okay, well, that's very promising. But yeah, thanks for your projection. And let's talk about sharding. Because I think a lot of people are curious about the current state of sharding. Can you update us on what's happening currently and, you know, what you're working on in terms of sharding?
Yeah, for sure. So one of the good news with sharding is that we've been able to dramatically simplify the problem. So when you think of a blockchain, there's usually two components to that blockchain. One is kind of coming to consensus on the raw data that goes in the blockchain, and then there's coming to consensus on the so-called execution engine. So for Ethereum, you know, we have the EV execution engine, and one of the realizations is that it's sufficient to have one single instance of the execution layer for all of Ethereum. And since we already have one instance of the EVM, ETH1 as it is right now, we don't need to have execution engines on all the shards. Instead, we can pursue this so-called roll-up centric vision, where we have systems that consume very, very little execution and instead consume a lot of data, consume all the data that's provided by the shards, be able to do this with the same kind of security that Ethereum provides, because you have the data availability layer with Ethereum grade security, and you have the execution also with Ethereum grade security, thanks to the EVM running right now on ETH1. And kind of another kind of nice thing with sharding from our standpoint as the research team is that the merge has been prioritized to happen before sharding, and so we have quite a bit of time in order to really polish and finalize the specs for sharding. But you know, as I said, we've been able to dramatically simplify the problem. So the process of writing and finalizing the specs for sharding should be relatively easy, and we should have it done by the time the merge is complete.
Wow. Thanks for the update. There are many L2 solutions popping out, and you know, does correlation between price and utilization deteriorate with greater adoption of L2s? And you know, there was this question on Twitter, and you know, I just wonder what you think of these L2s popping out, and there's this huge, you know, realm of L2s at this moment, and you know, what do you think about this?
Yeah, so an L2 is a scalability system that is able to retain the security guarantees that Ethereum provides. And so that's effectively a synonym for rollups. And so when you have systems like Optimism or Arbitrum launching, that's effectively, you know, the very first steps as part of the rollup centric vision. I mean, there's, besides the flexible rollups that can run arbitrary contracts and that are EVM compatible, like Optimism and Arbitrum, there's also dApp specific rollups, you know, specific to decentralized exchanges, or specific to lending, or specific to gaming. I think these dApp specific contracts are interesting, but they're not the end game. In terms of, you know, the consequences, the economic consequences of these rollups, I think there's kind of two very important ones. The first one is that the gas price, so the price of transacting in these rollups, will be dramatically lower than the price of transacting on chain. And so the barrier to entry as a user should be much, much smaller. The other thing that happens from an economic standpoint is the idea that economic density will increase. So what is economic density? Is this idea that every transaction on the base layer of Ethereum carries more weight. And you can kind of think of it like buses and cars, right? Like a bus is able to carry many, many more people per unit of volume compared to a car. And so the density, the transactional utility on the base chain will increase because we're effectively batching all the utility from many, many more people into these base layer transactions. And so one of the things that we've observed historically, and I think it's a trend which will likely continue, at least not reverse, is that the total fee volume at the base layer will increase, or at least not decrease. And this is important if we want this to be sustainable with scalability. So my personal prediction is that scalability is a good thing for fee volume, not a bad thing for fee volume.
Okay, thank you for insight. And there's many. I think there was another question that was that you might debate on, but the quadrilemma issue. And I think this person was trying to ask whether there's this decentralization, scalability, security, and finality, and finality and scalability are much different on the user experience spectrum. And some argue that ETH 2.0 appears to have worse finality than the current PoW Ethereum. There was this concern. What's your take on this? And what do you think?
Right. So I actually don't think there's such a quadrilemma. I think it is possible to have best-in-class decentralization, scalability, security, and finality at the same time. And I kind of disagree with the idea that the finality on the proof of stake is worse than the finality on the proof of work. I mean, one reason is because on proof of work, we don't really have this idea of economic finality. What is economic finality is the idea that you have a certain block whereby if you were to revert it, then a lot of funds, a lot of ETH would get slashed, would get destroyed. So this is something that proof of work doesn't have. Instead, what proof of work has is this idea of confirmations. And the process of blocks getting confirmations is very, very slow in the sense that one block provides one confirmation. So you have a proof of work block, you need to wait 13 seconds on average, and then you get another block and then you wait. And so if you want 10 confirmations, for example, you're going to have to wait on average 130 seconds. The way that proof of stake is architected is completely different, where the confirmations come in parallel through attestations. So you have large committees of attesters that in parallel get to vote for blocks. And so you can think of these attestations as being kind of real-time confirmations. And as such, you have a very high level of, I guess, pre-finality or confirmation in proof of stake much, much faster than on proof of work. So, I think proof of stake is strictly improving the confirmation and finality versus proof of work.
Thank you for your reply. I'm trying to be responsive to the community who are asking thoughtful questions. So thank you for that. Just hours ago, actually, before this interview, you shared the Twitter post on MEV research breakthroughs that proposed by Francesco. And it was very fascinating to see that post. But can you elaborate on why this is meaningful? Because it's a very interesting concept, and we'd love to hear your description about it.
Sure. So MEV stands for maximal extractable value, and basically it's the value that can be extracted by consensus participants in the process of participating in consensus. And so just to simplify this, it's basically transaction fees. So when you make a block as a block producer, you get to choose which transaction go in the block, and depending on which transaction you include and on which order you include them in, you'll be able to extract different amounts of value. Now, when we design a consensus layer at layer one, we have relatively fine grain and good control over the incentives within the layer one system. And that means specifically issuance for rewards, and it means slashing for penalties. But one of the things that we don't really have control over is the incentives at layer two around MEV. And it turns out that these layer two incentives, in the worst case, distort the incentives of layer one. They could be much larger in magnitude than the incentives at layer one, and they can kind of go against the flow of what we're trying to achieve with layer one. And the main problem is this idea of variance, MEV variance, which is that at different points in time, the amount of rewards that you can extract are going to change. And so that means that, for example, you're going to have a block with very, very valuable transactions, followed by a block with very few valuable transactions. And the reason this is a problem is because whoever creates the block, the second block with not so valuable transactions, has to ask himself an economic question as a rational actor, which is, do I build on top of the parent, which has all the valuable transactions, or option two, do I build on top of the block before that and kind of steal all the juicy and valuable transactions and include them in my block? And so there's this incentive for forking and for reorgs, which is really, really bad. And so what this breakthrough gives us is this idea of MEV smoothing, where we remove the variance and instead we kind of smooth it out. And the reason why we have a huge amount of variance is because a single actor, namely the block proposer, is in a position to capture all the MEV for this one period of time, which is 13 seconds or 12 seconds in the context of proof of stake. And so you have this very spiky reward curve. And so instead, the idea proposes that the committee members, which are those that are attesting the block and basically helping for the block to get confirmed and included on chain, they get the MEV as well spread out across the committee members. And so really this is a security upgrade which removes one of the potential systemic risks that MEV provides in terms of chain instability and messing around with the incentives that we've carefully crafted at layer one.
Oh, wow. Oh, so yeah, it was very new, a breakthrough. And, so right now it's, posted, but what stage is this, in basically, how is this going to be implemented? When is it going to be implemented? Just, is it in the initial stages? Yeah, very interesting breakthrough. Yeah.
Yeah, I mean, just as disclaimer, these are very recent ideas. They're just a few weeks old.
Okay.
The good news is that these ideas have been discussed, internally within the Ethereum Foundation, and oftentimes when you have a breakthrough idea, you need to ask yourself, is this too good to be true? Surely I'm missing something. Yeah. Why did people not come up with this before, et cetera, et cetera. So we've done a fair amount of due diligence, and as far as we can tell, there's no kind of deal breaker, from our internal due diligence. One thing that you've mentioned is that this idea has now been published publicly on ETH Research, and various people have had a chance to look at it now. And so for example, there's the Flashbots community. Flashbots is kind of a project that focuses on MEV. They've had a chance to look at it, and some of the Flashbots community members have, really liked it and kind of publicly said that they agree it's kind of a big deal. Yeah. So far it's looking pretty good.
Wow.
But in terms of the process of having it implemented, it's the same process as last time. So we really need to do more research and convince ourselves that this actually works. And then we would need to go ahead and write specs, and then we would need to go ahead and implement it. I mean, one of the things that I'll mention is that this idea uses another idea as a dependency, and this other idea is that of separating block building from block proposing. So basically, if you want to build an optimal block on Ethereum, you need a lot of resources. You need to have access to the state of Ethereum, but you also need to have access to the state of all the rollups, and even to state in the real world. Basically, one example is if there's an arbitrage opportunity between one rollup and another, then the only way that you can go extract this arbitrage opportunity is to be aware of these rollups. And so the process of building blocks is a difficult one. And on the flip side, we want consensus participants to not have to do a lot of work, right? We want people to be able to be a validator using a Raspberry Pi, because that gives us a lower barrier to entry to become a validator. And so one of the things that we're doing is that we're separating the complicated process of building the block versus the easy process of selecting the optimal block from all the proposals and including that block on chain, which we call proposing.
So that's also in the process, as in line with the recent research breakthrough. Oh, wow, interesting.
Yeah, so that's something that we will likely be implementing, this proposer build separation with sharding.
Wow. Oh, very interesting. Thank you for sharing that. And I was just going to mention, I was just going to ask, what do you think Ethereum needs more development on? But I guess there's so many things that are in development. And, is there anything else that you think, might need more work on? I'm sure there's many things in the process, but are there any more areas that need research on, if the Korean community or would love to participate, what can it be, or just curious on that as well.
Right. I mean, one area where there's a lot of work still to be done is basically various cryptographic upgrades, mental security. And there's a handful of them. So if you're a cryptographer, we've actually started building a team internal to the EF, but there's still a lot of work to be done there. And as a general theme, as blockchains become more and more sophisticated, they're going to rely more and more on advanced cryptography, and ideally less and less on incentives. And the reason the cryptography is, as I said, it's a sub branch of mathematics, and so it's a piece of be relied upon strongly, whereas the economic layer and the incentives is much more difficult to work with. It's much more mushy layer that is more open to being abused.
Cryptography, yes. I'm sure. I mean, there is definitely a cryptography community in Korea that's interested in, contributing. So, I think there would be opportunities for further research and collaborations, in upcoming years. Just out of curiosity, but I mean, since you're dedicated to, Ethereum Foundation, but still, are there any, projects outside of Ethereum, that you might be interested in, or you're fascinated about? It's so much going on. So.
Right. I mean, I like thinking about which ecosystems are complementary to Ethereum.
Fair.
And I think one very, very good one is, for example, Filecoin. So Filecoin can give us kind of a decentralized storage layer which works at scale. So, you know, if you go back to this idea of Satoshi trying to build a decentralized peer-to-peer marketplace, that's another layer of infrastructure that needs to be provided in order to fulfill that vision. And you need to go well beyond digital gold to achieve that. Because basically, if you're going to have, for example, a decentralized eBay, you need to have a place where you're going to store all the photos and all the information around what you're selling and whatnot. And so that can go on IPFS, and you can have a persistent, you can incentivize the persistence of this data using Filecoin.
Oh, thank you for that. Oh yeah, I have my plans to interview Juan in the near future. So yeah, that'll be very interesting to ask his point of view as well. Last question. You know, you've been in the foundation for a long time, but what is your ultimate vision in all of crypto, but you know, in crypto, also for Ethereum, but just curious about your personal vision and seeing how the space is progressing and how it will progress. It's very curious. Yeah,
I mean, as I said, I think my vision, and it's not mine alone, a lot of people share it, is this idea of the value. And you know, there's various reasons why this is the case. You know, one key one is permissionlessness and composability. So anyone can come in and kind of build upon what already exists and compose and kind of keep adding goes. Now, in terms of how I think this story will unfold, I think it'll be very, very similar to the internet itself, which is namely that you know, the need, the desire to provide more and more utility will push the limit of scalability and will kind of force us to do these engineering upgrades to continuously cater for more and more demand. And so I kind of have this long-term vision that I call ultra scalability. What is ultra scalability? Is this idea that a single platform such as Ethereum could cater for essentially all the transactions in the internet of value. But we're quite far from there. And you know, it's a story that might take 20 years to unfold. But during these 20 years, I think we're going to have progressive increase in scalability. Now, in terms of where the scalability will come from, there's basically three places. One, which we've talked about, is the rollups, and that provides roughly a factor of 100x scalability. And then there's sharding, which in the short term will provide roughly 100x, but maybe we can push it to 1000x. And then there's this other thing which people usually don't think about, but it's actually really critical, is basically the latent improvement in computational resources in general. So basically Moore's law. But when we think about decentralized blockchain systems, we need to be a little bit more granular than Moore's law. Especially that Moore's law, you know, kind of what it means is that it is kind of related to computation, right, and CPUs. But it turns out that there's four key bottlenecks, computational bottlenecks in the world of blockchains, and only one of them is a fundamental bottleneck. So there's CPU, there's storage, there's disk I/O, and there's bandwidth. Now, it turns out that for the first three, you can use very clever kind of cryptographic and engineering tricks to remove the bottlenecks. So it doesn't really matter if, for example, the CPUs become bigger and more powerful. We would still be able to scale so long as the amount of bandwidth scales. And one of the good news is that bandwidth is scaling at roughly 50% every single year. And there's no reasons to believe that it will stop scaling for the next 20 years. And so we'll be able to enjoy several orders of magnitude scalability on top of both sharding and rollups in the decades to come.
Thank you so much. I think, I also agree that this is just a very, very early stage in development of crypto. And, I think within the, first recent several years, let's see how Ethereum has evolved and developed. It's crazy. And I think for more years to come, I think we'll see more exciting things happening. And, thank you for all the, contributions to the community and to Ethereum. And yes, it was amazing to hear your insights. And I think the community will learn a lot from, your perspectives and also benefit from your contributions as well. So thank you so much.
For sure. Yeah. And thanks for having me.
Thank you.